stuff in this little bit of time that we have. Okay, so can you guys all see my screen firstly? Thumbs up if you can. Okay, perfect. All right, so this is going to be the lecture notes that we go through. Of course, in 1 hour a week, there's not going to be much we can do in terms of going over content. I'm going to rely on you guys to be reading the stuff ahead of time or later. Is there a hand up? There's a hand up. Okay, Lana Thompson, do you want to say something?
Sorry, it was by accident.
How do I get to the chat here? Okay, is that an accidental hand up? Okay, hand is down again. It's okay. All right, if you guys want to say anything, you're welcome to put it in the chat, or you can put your hand up, or you can just unmute and let me know. Because as I'm talking, sometimes it's difficult to keep track of the chat. Okay, anyway. Firstly, just let me know how many people know how to get access to the module manual, the module outline, and ARC. If you know how to do that stuff, just give me a thumbs up. Yeah. Okay, that's good. Most of you. Okay. And do any of you guys have... Okay, that's all good. Yeah. Okay, very good. More than I hoped. That's good. Okay. And how many people have the module outline and module manual for this module? If you guys have it, give me a thumbs up so I know. Okay, excellent. Excellent. So that tells me you guys know how to operate around and get things that you need to. That's perfect. Also, since you guys know what's happening, okay, no, hang on. I uploaded something to ARC, but no, you guys, I don't have access to the online group yet. So, okay, the lecture slides will be uploaded as soon as I can. As soon as I have access to your group, I'll upload the slides, but the slides are based off of the module outline. So it's literally just snapshots of the module outline here and there. Maybe I added a little bit of text in a few places if I thought the explanation was not clear enough, but it's pretty much the module, sorry, not the outline, the manual, the module manual, just screenshotted here and there. That is going to be you guys' main resource, the module manual. Right, the lecture notes is pretty much a summary of that. The module manual is where you can find everything you need. And if that still doesn't feel like enough, then there are some prescribed textbooks for you guys to look at, right? That you can find that information in the module outline. And I think the module manual as well. Yeah. So all of that stuff, you can have a look. I think there are links as well to get PDFs. Okay, let me just have a look at the chat. Please can we have guidance from you on how far we have to be before the next lecture? Okay, no, I appreciate that. Okay, so let's see. It would be good if we can. Let me try and work this out, right? It's a maths class. We can work it out. We have 5 learning units to go over, and we have, how many lectures do we have altogether? I think we have 12 or something like that. 10 to 12. So every time I see you guys, we need to cover at least half a learning unit. Right? So yeah, we can keep it like that. If we can cover at least half of learning unit 1 by the next time I see you guys, that would be good. That's a good place to get to. Okay, and a good guide of what to be going over in the learning unit will come from the lecture notes itself. Sorry, the lecture slides will be a good guide. The module manual is also a good guide, but they put a lot of unnecessary stuff there. It's good for you guys to read it, but the lecture slides will streamline it. So if you're finding that the module manual has too much of stuff, there's a lot of unnecessary fluff in between that you can ignore if you're rushing for time, the lecture slides is the guide to tell you what to do there. So again, we'll have that to you guys as soon as we can. Okay, so anyway, since I'm sharing my screen, let me show you guys the lecture slides so far. You can see again, it's just screenshots from the module manual. So the module purpose, right, all of the stuff you guys can read. We have 1 hour a week, so we don't have too much time to look at all of this. Basically, it's saying they're going to teach you guys how to think like computers and giving you mathematical foundations to do that. Okay. And prescribed textbooks, things like that, you can find that in your time, right? The different learning units. Let's see, very quickly, what we're going to be doing is basically learning unit 1 and 2 are both very mathematical. Learning unit 3 is also mathematical, starting to border on a little bit of thinking like a programmer. Learning unit 4 and 5, especially 5, gets us full on into sort of a programmer's way of thinking about maths. You know, there's this thing that we look at called truth tables, which is kind of like logic gates. Many of you guys would have heard about this already. So that's one of the things we work towards and thinking about uh, different number systems, you know, binary, things like that. So that's where we're going to try to get. Okay, so very quickly, again, definitions, I'm going to just go over quickly because what we need to be doing probably is examples. That's the best thing for you guys to learn. Examples. So unfortunately, I'd like to cover all of this, but I don't have time. You can read it in your own time. Place value charts is just a helpful way to read large numbers. Like in this example we have up here. Um, I'm pointing with my mouse. Can you guys see my mouse? Just give me thumbs up if you can. I probably need to open the chat now to look at that. Can't see the mouse. Okay, excellent. Okay, so place value chart, for example. We look at this first example here. There's a big number here. If you try to read this number just off the top of your head, it's a little bit tricky. But if I put this number into the place value chart, it will be easy to read, right? And what I'm going to do as well is upload the videos of the actual in-person lectures. So I'm lecturing the same module in person in Varsity College. So all these examples where I talk about this and pasting it in here, trying to read the number, all of those things you can see in those longer lectures. If you feel like I skipped through something that you wanted to see, go check those lectures which will be uploaded and you guys can see those things. So yeah, that's actually very useful. So I'm not going to waste too much time explaining theory because all of that will be there. I should mention this thing here, though. Expanded form is a thing which is where you're going to get a lot of marks. Just bear with me. Let me flip this laptop over so I can write as well. Flipping over and getting this pen ready. So this right here, no, did I miss a line? Sorry, I missed a line. All of this. See, it's telling you to write 264 in expanded form. It basically means just write it as this here. 200 plus 60 plus 4, right? That's easy stuff to do. 264 is 200 plus 60 plus 4. So if you are told to write a number in expanded form, that's all you need to do, and you get a fair amount of marks for this. All right, so just keep that in mind. It's one of the easiest ways you can get marks. There's an example for you guys to try. Express this big number in expanded form. Just break the thing up, right? That's all we do. So I'm just going to go over the examples. So this is going to be 1 with how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Excuse the untidiness sometimes. 2 with then 7 zeros. 1, 2, 3, 4, 5, 6, 7. 9 with 6 zeros. 1, 2, 3, 4, 5, 6. There's a 0 here, so we ignore that one. After the 9, the next 9 should have, I lost count now, how many zeros? 1, 2, 3, 4. 2, 3, 4, and so on, right? You guys get the idea. 7 has 1, 2, 3. I don't know why weird things are happening with this pen, but anyway. 1, 2, 3. Oh gosh. Let's try that again. 6 has 2 zeros, yep. 5 has 1, and 8 has no zeros. Right, simple as that. So that's standard form. If I lose anybody and you guys want me to repeat something, just catch me in the chat. Say something in the chat. I'll check it from time to time. Where is the thing? I've lost it already. Check the chat. Okay, so far everyone's good. Yeah, we can do that. We can get a WhatsApp group going. Yeah, so if you guys want to make that and include me, let me know. If you guys want me to make it, oh, you guys made it already. Perfect. All right. So I'll get onto that as soon as we're done here. Thank you very much. You guys are helping me a lot. Inequalities, read up about it in your own time. Sorry, I'm going to be saying that a lot, right, as we go through this. Read up about it in your own time. Less than, greater than, equal to. Many of you probably know what this is already. If not, just read up. Estimation is basically dealing with rounding. Now, if you look at the module manual, it's going to give you a whole lot of unnecessary stuff here. So this is one of those examples of places where I say we streamline in the lecture notes. The module manual gives you a bit too much. Read if you need to, but I mean, you guys are mostly working people and stuff. So trying to save time, you just need one slide. That's all. Properties and laws of whole numbers. Okay, so let's see what we're looking at here very quickly. There's a nice summary on the side here. See these little blue things I put here, this one and this one. Now I mentioned these things because in multiple choice, I'm not sure if you guys write, you don't write a test, you write an assignment, but you still might get multiple choice and some theory questions where you asked, for example, what's the addition property of zero? Basically, addition property of zero says that zero added to anything doesn't change that thing. So if zero added to A does not change A, right? It doesn't change anything. Multiplication property of one down here, same story, right? One multiplied to anything does not change that thing. So that's all those two things are telling us. Let's see, what are we looking at now? Commutation. And I guess we look at association. So commutation very quickly means that you can change the order in which something happens, but it doesn't change the answer. So look at this example in blue down here. 3 plus 2 is the same as 2 plus 3. So that tells us addition commutes, right? You can change the order, but it doesn't change the answer. And very quickly, I can look down here at this first example. Hope you guys can see me pointing with the cursor here. Anyway, the first example is subtraction commutative? Check with an example. We can immediately say it's not, right? It isn't commutative because 3 minus 2 and 2 minus 3 are not the same thing, right? So this is not equal to one another. So subtraction does not commute. Is multiplication commutative? Yes, it is. Check with an example. Sure. 3 times 2 is the same as 2 times 3. If anyone disagrees with anything I say, just stop me. Unmute if you want to, whatever. Is division commutative? Check with an example. I think it's fair to say no, it's not commutative. I'll leave that to you guys to check out. Okay. Association just has to do with brackets. Again, I'll be doing more detailed examples in the long videos for you guys to see, but here's one example of it right here. So basically this versus this at the bottom. Right, you can see all that was done from these two is that the brackets moved, nothing else moved. So that's association, means you move the brackets, but the final answer does not change. Right, and we can see the full working on the right to check whether the final answer on the top is the same as the final answer on the bottom. Yes, it is, no problem. We're happy, both give us 15. Right, and there's a problem here for you guys to check. Is multiplication associative? I'll give you guys a hint immediately. Yes, spoiler alert, it is, but you guys can check it. Try to think of an example. Maybe use the same example we did above, but instead of addition, use multiplication and see if you get the same thing by just moving the brackets. So the two additions become two multiplications and check if you get the same thing. All right, that's a good check to do. And again, you guys can check the full details of this example in the long slides. Okay, but maybe let's just do one for now. So we've done something. Let's do number 1 and number 2. Were the following rewritten using commutation, association, both, or neither? Right, number 1, we can see clearly we just switched the order. That's all we did. Switching the order is commutation. So the first one is commutation. Right, the second one, what did we do? 1 plus 2 plus 3, 1 plus 2 plus 3. Both of the sides of the equals to sign are the same, except the brackets moved. So this is association, right? Let's just do one more. This third one looks interesting. 3 plus 2 plus 4 becomes 4 plus 2 plus 3. So again, this is a situation where only order changes. There's no brackets. So commutation has happened here. Okay, I feel like I'm going really fast, guys. I apologize, but I hope everyone's still okay. All right, again, just communicate with me if you're not. It's not a problem. Okay, distribution property of multiplication. Okay, so many of you would probably already know this. If you haven't, this might be a recap. If you have a number multiplied into a bracket, you can simply distribute the number over the bracket, like what was done here in the first line. See, this here became this, right? It's just a way of you don't have to do this. This is probably more useful when you start doing algebra, because the left-hand side here can be simplified as it is, but it's just a way we can do things. So we can distribute the 3 into the brackets, and it becomes 3 times 10 plus 3 times 2. So that's just a way of doing it. And at the bottom, they show us it doesn't matter which way the 3 is, but it can be in the front, can be in the back, and it's just because multiplication commutes, right? We've seen that above already. Something times 3 is the same as 3 times that something. So the order doesn't really matter. Okay, example at the bottom for you guys to try. Order of operations. Okay, so this is where something a little bit interesting happens. Board mass. Most people see this and they think very simple, very easy. And I'll be honest, it is not too bad. But there's a few curveballs in board mass that many people sometimes forget. Honestly, including myself. When I first looked at this again, I thought I knew this from high school, but let's just check and make sure we remember all of this, because it'll help you guys when you're doing the examples and the ICE tasks and stuff like that. Yeah, so let's see if we remember what everything stands for. I'm sure we do, but let's see if we know what everything represents as well. So the B, I'm sure everyone knows this is brackets, right? Let me just try and write as neatly as I can. Brackets. Okay. But brackets doesn't only cover brackets. There's one other thing that's covered in the B. And let me just see in the chat if anyone can tell me what it is. Right? Don't be afraid to be wrong. In these lessons, just say what you think. It's okay. I want everyone to be free here. It must be like an open discussion, because even I make mistakes very often, as you guys will see. Sometimes I'll see 4 cubed and I'll have a panic attack. I'll get the wrong answer and I'll ask you guys for help. It's okay. We all make mistakes, right? Does anyone know what the B could represent? Okay, I see a hand up. Okay, whoever's hand that was, it's gone now, but you can say something if you want to. The floor is yours, or you can say in the chat.
Good afternoon, sir.
Any ideas? Or if you want, you can just Google it and then act like you knew it. That's fine as well. No problem.
Hi, sir. How are you?
Okay.
Hi there,
All
so
right.
can you
Unfortunately,
hear
guys, I'm
us?
sorry. I can't also spend too much of time waiting for answers, even though I want to. I don't mean to seem like I'm rushing. Please don't take it as me being rude.
Okay, so
But anyway,
another thing
unmute
called
at any time if you want
brackets.
to. Now,
It
how do
is
I get back to the thing I
parentheses.
was sharing? There we go. Brackets also stands for, I mean, it's weird, but brackets obviously encompasses brackets, parentheses, all these different ways of saying brackets. Also, fraction bars. So it covers brackets and fraction bars. These are the kind of things they like to catch people with in multiple choice questions. So by fraction bars, I mean, suppose I had 3 plus 2 over 1 plus 3. For example, we would treat the top of this fraction as a separate thing and apply board mass to the top. Then we treat the bottom as a separate thing and apply board mass to the bottom. Just like how a bracket breaks things up. Like if you had a bracket here, 2 plus 5 plus 1 plus 3, whatever. Those two brackets, we consider them separate things and apply board mass inside them first. Then we look at the total sum. That's the same thing that happens with the fraction bar. With this right here. Numerator, denominator, we work with it separately, and then we simplify at the end. Okay, so that's an interesting one. B. O stands for off, which is not a very descriptive thing. I'm going to put you guys out of your misery now, because a lot of people forget what this one stands for. People think multiplication, which in a way is correct, but not fully the answer I'm looking for. What I'm looking for here is exponents. That's one thing. And then the opposite of exponents, which is square roots. Sorry, not only square roots, any kind of root. Exponents and roots. Right, so for example, always nice to give examples. 2 squared is 1, that's an exponent, or the square root of 4, which will give you 2. And so these are 2 examples. One is an exponent, one is a root. Okay. All right, and the others, I think these are the ones people usually remember. Board mass. This one here is just division, multiplication, addition, subtraction. Okay, but one more slight curveball here, which people don't always know, and that's okay. I even forgot this one myself, is that the division, multiplication, addition, and subtraction, they form groups. So division and multiplication are a group. And from here, when you're working through an expression, you look at the expression left to right. Let's give an example. 2 plus 3 divided by 4 times 2, something like this. You start looking at the expression left to right. So we start with the 2, work our way to the 3, the 4, and then the 2 again. When doing this, if you come across, let me get a different color here. If you come across division first, then you do division first. If you come across multiplication first, you do multiplication first, even if it's before division. Right, so these form a group. So when you're moving through the thing left to right, whichever one of these you meet first, you do first. It's the same at the bottom with the addition and subtraction. Okay, so maybe we'll work through an example and see if we can demonstrate this. So in this example that I have here, let's see, we have no bracket, we have no exponent or root. Okay, so the first thing we look for is either division or multiplication. Let's see what I meet first. First, I meet a division, 3 divided by 4. So I'll do that first. Okay, and that's okay because that's consistent with the order of BODMAS anyway. But if I had 2 plus 3 times 4 divided by 2, for example, then in this case, what I will do first is obviously not the addition because that's at the bottom in BODMAS. I will do this first, 3 times 4. Even though multiplication here is at the bottom, it's under division, right? But you meet it first, so you do it first. That's why these form groups. Okay, I hope I'm not rambling and confusing anybody. I hope this is making sense to you guys. If anyone gets confused, just let me know. Okay, so that is BODMAS.
Do you mind going through it? Do you mind going through it again?
Yes, anyway, we covered all of this. Any nuances with the last 4? Yes, we covered all of that. Okay.
You can't hear us at the moment.
Examples for you guys.
His sound is muted there.
Might be nice to be
I
doing some of
figured.
these examples. Let's see, and it's not in class, so I'm going to be on my own with these. But anyway, let's see. Don't want to waste too much of time. Maybe I should try the second one. Okay, actually, the third one has a nice bracket there. So let's look at that one. Okay, so let me just go for it. If I make any silly mistakes, just stop me, right? Or just put your hands up, say something, unmute, whatever. So let's see, the first thing we must do is simplify within the bracket, of course, right? So within the bracket, what do we meet first within the bracket? So we have an addition and a multiplication. So the multiplication must happen first, right? So this here, the 6 plus 8, 16, 24, right? I think I remember my timetables. We'll see how that goes. Okay, so still now we need to still work within the bracket before we do anything else. That's the main thing of BODMAS. Sorry, not the main thing. The first thing is brackets. So 24 plus 6 is going to give us 30 here. And then we still have the minus 10. I need to make some space. Let me move up here. So now the next thing we must do is division according to the order of BODMAS. So 900 divided by 30 is, no, there's a 3 there. It's 30, right? Yeah, it's 30. And then minus 10. So minus 10 is the last thing to do. So that is the only thing left. 30 minus 10 gives us a 20. Okay, so again, these are simple things to do. And the nice thing about a BODMAS calculation is that firstly, you can always put this into your calculator and it will always give you the correct answer. So you can know ahead of time what you're working towards. That's always helpful. But please don't just write that as your answer. It's nice. You need to show you're working because, you know, some of these questions will be worth 5, 7, 10 marks, whatever, depending on the length. And if you just write an answer, then of course I can only give you marks for the answer, which is usually like 2 marks or something. So it's always safer to show more rather than to show less. I can never mark you down for showing too much work. Okay, and some people don't like BODMAS to use PIMDAS, which is really the same thing. It works out to the same thing. So if you prefer this, you can use this. Apparently this is a thing. I didn't even know about this. But then again, I think this is a new thing in school. I'm quite old now compared to many of you guys probably. Okay. So what are we looking at here? We want to define expressions. Let me just define it quickly with an example. That's the easiest thing to do. So let's suppose I had 5 plus 2. This is an expression, right? By the definition, it's a combination of, let me just find the words I'm looking for. It's a combination of symbols and numbers, right? We can also use variables, operations. By operations, we mean plus, minus, multiplication, division, all those things make up an expression. So something like 5 plus 2 is an expression. Something like 5a plus 7 squared divided by 8 squared times b, where a and b are variables, that is also an expression. All these things are expressions. But if I take this, let me delete the first one. If I take this example and say equals to 2a, now this is an equation. So this entire thing is an equation. And if I look at each individual side of the equals to sign, this here is an expression. This here is also an expression. So expressions are usually the things you find on either side of an equals to sign. Okay, sometimes you may not be given it in terms of an equation. You can just be given the expression alone. You could just be given this here without an equals to sign. That's okay. That's still an expression. Okay. The distinction between these two is more important than the definitions themselves. So just remember this distinction. Okay. Well, it's amazing how much I can get done in an hour when there's no one in class actually saying things. It's a bit weird, but it feels weird. It's like I'm talking to myself. Okay, anyway. Substitution and evaluation. Again, I'll just quickly explain what this means, and you guys can try examples at home. Example, you are given, I'll do one basic example. You're given something like this here. Evaluate 24 minus x when x is equal to 3. So the evaluation part, the substitution part actually comes first. So 24 minus x becomes 24 minus 3, right? I just substitute the 3 into that. That is the substitution part. So this is the substitution step. Then the evaluation is to just get the answer. 24 minus 3 is 21. That's the evaluation step. Right? So substitute first, then after you substitute, you can evaluate. Okay, there's examples here for you guys to try. Again, which you can check. You can check with the long video. That should all be done. Okay, or most of it. Sometimes I skip them and give it as homework, but if any of it is not obvious and you're struggling, you can just message me on the WhatsApp group or email me. Yeah, but anyway, you have my number. It's easier to WhatsApp. Okay. These sections, I left them as sections to read at home because these are the ones I mentioned. I mentioned that there are a lot of sections in the module manual that are just fluff. There's like no real content to it. In fact, these are not only fluff, it's weird, right? It shows you how to add and subtract in a very weird way, which is not necessary. I mean, we couldn't have gotten this far in the notes without knowing how to add and subtract. So I don't think we need to really go into the details of how to do it. If you're interested, you can read it, but don't stress too much about it. Okay, resultant signs when multiplying different signs together. This probably many people know already, but we must cover it just for the sake of knowing we've covered all bases. If I take a positive number times a positive number, you get something positive. So 2 times 2, let me not use the same numbers. 2 times 3 gives us 6. If I take a negative and a negative, you get a positive. So negative 2 times negative 3 is 6. Again, you guys probably know all this. Negative 2 times positive 3 gives you a negative answer. And positive 2 times negative 3 gives you a negative answer. So the rules are summarized here in this highlighted portion here. Okay. All right, these are just examples. It doesn't have to be 2 and 3. It could be any two numbers. Okay, so that's that. And here's important words to know. In terms of theory, these are words we need to know. Additive identity is a fancy way of saying 0. Multiplicative identity is a fancy way of saying 1, right? Additive identity, we call it 0 because, sorry, 0 is additive identity because identity is usually a word used for something that doesn't change something else under a certain operation. So under addition, 0 doesn't change anything. 0 plus a, for example, is just a. The 0 changes nothing under addition, so it's called the additive identity. Multiplicative identity, same reasoning. 1 changes nothing under multiplication. 1 multiplied by a gives you a as an output. So just things to remember. Additive inverse at the bottom here is just the negative of a number. So for example, if I take 7, the additive inverse of 7 is just negative 7. Right? It's just the negative of a number. I'm not sure why we need to know that as a definition, but I don't set the tests and exams and assignments and everything, so I don't want to just skip things with you guys. What they say we need to know, we must go over it. So that's additive inverse is just the negative of a number. Multiplicative inverse is just a quotient, or it's simply 1 divided by the number. So for example, if I take 7 and I ask you for the multiplicative inverse, it's just 1 over 7, right? Or if I take 3 over 2, for example, 1 over 3 over 2 just gives you 2 over 3. But it's like the inverse of the number. Okay, if you want to see this more clearly with the first example, let me just do it again. 7 is the same as 7 over 1 technically. Invert that, you get 1 over 7. All right, so just remember individual numbers are always technically the same as the number divided by 1, in case I lose anybody with that. Okay, 2 examples at the bottom. Again, I should mention here though. Example 1, let me do at least the, actually we should cover these. What's additive inverse of 8? It's minus 8. Prove it. How do you prove it? We need to know how to prove that. So to prove that, you take the original number, you add it to its additive inverse. 8 plus minus 8 is the same as 8 minus 8, and you get 0 as an output. If you get 0 as an output, that's how you prove it. That's the thing proven, right? So example 2, what's the multiplicative inverse of 8? Prove it. Okay, multiplicative inverse of 8, we know from the top is just 1 over 8. How do you prove that? Well, you take 8 and multiply it by its multiplicative inverse. You end up getting 8 over 8 as a result, which is 1. So if you get 1 as a result, you've proven it, right? We're done with that. So for multiplicative inverse, the proof involves getting 1 as an output. For additive inverse, the proof involves getting 0 as an output. Okay. Okay, dividing is the same as multiplying by the reciprocal. Yep, that's true. And we should, instead of looking at this table, look at one example so we can make that clear. This example at the bottom. Let me keep that statement up there so you guys can see it. Dividing is the same as multiplying by the reciprocal. Reciprocal is the same as multiplicative inverse, what we just learned up here. Right, so this example at the bottom, 2 divided by 4 over 3 is the same as 2 multiplied by 3 over 4, right? And that helps us because multiplication is a lot easier to work with for fractions. 2 is technically 2 over 1. Why does this keep happening? 2 over 1 multiplied by 3 over 4. And from here, multiplication is easy because you don't need to find a common denominator. There's no tricks. You just literally multiply the top and multiply the bottom. So 2 times 3 at the top, 1 times 4 at the bottom, and this we can do easily, right? We get a 6 at the top, we get a 4 at the bottom. Of course, you can simplify it further if you like, 3 over 2. Okay, another example, suppose I should make this clear, right? Suppose I had 4 over 3 divided by 2. Suppose it were this way, right? Then the way that we can use the rule above, not really a rule, but the way we can use this helpful information is rewrite this as 4 over 3. Let me first do this, write the 2 as 2 over 1. Right, now to use the rule above, 4 over 3 multiplied by the reciprocal of the second fraction, so it's just a half. And from here, it's easy to simplify. 4 times 1 on the top, 3 times 2 at the bottom. You get 4 at the top, you get 6 at the bottom. This is the same as... Does something go wrong here? No, I think it's fine. 2 over 3. Okay. All right, I should probably check the chat from time to time, shouldn't I? Let's see how we're doing. Okay, all good. Someone said my sound is off a while ago. I hope. Oh gosh, it's on now. Okay. You guys can hear me, right? Please tell me you can hear me. Please tell me I was not talking to myself this whole time. Give me a thumbs up if you guys can hear me. Okay. Oh gosh. I had a mini heart attack there. Okay. My first lecture without sound, you guys are going to get me fired. Sorry, I'm blaming you. It's all my fault, I know. Okay, anyway, where was I? Okay, let's see another example. It's an evaluation example. Okay, very similar, but again, examples are better than going over notes. So let's look at an example. Find 4x divided by -6 when x is equal to -2/3. So first we need to substitute and make this into a problem that's more easy to digest. So this will be 4x divided by -6, which is the same as 4 multiplied by, with the substituted value, -2/3. And I just substituted for x divided by -6. Okay, now the 4 we can write as 4/1. The -2/3 is still here. Okay, divided by -6, we can write it as 6/1. Okay, now we have a multiplication on the left and a division on the right. Now by board mass, whichever one we come across first, we do first. So this right here, these brackets here, just represents multiplication. So this is technically the same as, I'm writing it in a different way in case anyone is getting confused by it. This is the same as 4/1 times -2/3 divided by -6/1. And in a fraction, you'll notice now I took the negative. So with the 2/3 fraction, the second fraction, I took the negative to the top. It doesn't matter where you have the negative, top or bottom. In fractions, it doesn't matter. If you have a negative, put it where you like. It gives you the same answer. So I put it at the top for whatever reason. Okay, so first we do the multiplication. So this will give us 4 times -2 on the top, 1 times 3 at the bottom, and then divided by -6/1, that doesn't change. So on the top here, 4 times -2 gives us -8. The bottom is just 1 times 3, which is 3, divided by -6/1. Now we can do this in two ways, and I'm going to choose the easier one. We can realize that this is basically a negative divided by a negative, right? This is a negative number here, this is a negative number here, and we're dividing them. So a negative divided by a negative is going to give you a positive, sorry, as an output, right? The rules are the same as with multiplication. A negative times a negative is positive. Similarly, a negative divided by negative is a positive. So we can just exclude the negative already and just write this as 8/3 divided by 6/1, right? Because it's going to give us a positive number anyway. If that confuses you, though, you don't have to do that. You can keep the negative until the last step and then see it cancel out. Right? If you wanted to, you could go that route. So here we just use the rule we learned. 8/3 multiplied by the reciprocal, which is 1/6. Okay, so this becomes 8/18. Okay. Anyway, simplification further, you guys can do that. If you're not sure how to do that, calculators. Just trust your calculator, right? If you're not sure. Okay, because simplification to the final stage, like here, we can simplify this to, let's see, both are divisible by 2. So on the top, we'll get a 4. At the bottom, we'll get a 9. Right? Can this be simplified further? Are they both divisible by the same thing? I don't think so. Okay. But anyway, from here to here is the point I'm trying to make. This is calculator work. You don't have to show working. Simplifying fractions further is just one step, right? So if you're not sure in general, it's safer to just use your calculator. Okay. Integers, we're doing a recap of something we haven't covered yet. Interesting. Let's see, there's a summary somewhere. I'm sure there is. So we'll summarize all these different number types at some point. But for now, very quickly, integers, to understand what this is, it's helpful. Let's first quickly understand what's a natural number. Very simple. A natural number is just a counting number. 1, 2, 3, 4, 5, 6, 7, going on to infinity. The numbers that come naturally to you when you try to count, right? So if you want to count, for example, how many computers are on a table, you count 1, 2, 3, 4. Those are natural numbers. They come to you naturally. Whole numbers is the same as natural numbers with the inclusion of 0, right? So this and this are pretty much the same. You're just now including 0. Okay. That's all that happens then. The integers can be thought of as the positive and negative of the whole numbers, right? So you see here, there's your whole numbers, and then there's the negative version of them. So that's all that's happening. Right, so integers does not include anything in between, like a half is not an integer. It's all just these numbers, exactly the numbers you see and going on to infinity, nothing in between though. Those are integers. And why we need to know that is because it helps us to define absolute value, which we see at the bottom here. I'm looking at the slider, we're already like halfway through this, which is very good. We're reaching a good place today. Okay, anyway, absolute value at the number line. An absolute value which is denoted by, for example, if we want to take the absolute value of 2, we denote it by a 2 with 2 lines next to it. That's the absolute value. And simply what it gives you is the positive version of a number. So for 2, it doesn't matter. The answer is 2. But if I took -2 and I want the absolute value of that, the answer is 2. Right? So it just takes a number and gives you the positive version of that number. That's the simplest way to think about it. Technically, what it is the distance on a number line to your number from 0, like without 2 example. If I have a number line here, 0, 1, 2, 3, -1, -2, -3, the absolute value of 2 is represented by the distance from 0 to 2. Right? We see we've traveled 2 units to get there. So that's the absolute value of 2. And similarly, the absolute value of -2 is the distance we travel from 0 to get to -2. So we travel 2 units to get there. We travel 2 units. It's like a scalar quantity. We don't consider direction here. We just travel 2 units. So the answer to absolute value of -2 is also 2. The distance we moved is 2. Okay. All right, there's some examples at the bottom for you guys to try. We'll just look at one quickly. Absolute value of -4 is simply 4. Right? Very straightforward. Let's look at another one. It's easy. Absolute value of 7 is 7. Perfect, right? We know how to do that. No problem. Okay, opposites. Again, just a definition we need to know. The opposite of a number is just the negative of a number. I don't know why this is a thing, but it's a thing. So for example, if we look at 7, the opposite of it is -7. Like that's it. That's all we need to know there. Not sure why we put an entire slide for that, but anyway. Some more read at home sections, which again, these 2 sections are, if you ask me, not very necessary. But you can look at them if you want to, but don't take them too seriously because we know how to add things with the same sign and different signs. If you are but confused by that, have a look at it. Check if there are some examples to help you. If you're still confused, you can let me know on the WhatsApp group, but these are mostly not too difficult. I should say very straightforward, right? But again, if you don't, many of you would have not seen maths for years probably. So if you're confused by these things, it's okay. It's normal in the beginning. Have a look and try to catch up. That's okay. Rational numbers and real numbers. Okay. So this is where things get a little bit annoying, but anyway, let's not panic. We can do this. Rational numbers need to be defined. Okay. So again, quick summary. We've defined natural numbers. I'm going to just call it n. That's, I think, the symbol used for natural numbers. It's like an n with the italic kind of vibe to it. Natural numbers we know are 1, 2, 3, and so on. Whole numbers, I think this is the symbol, the W. I'm not sure where the thick part of the letter goes, but anyway, something like that. 0, 1, 2, 3, and so on. And you guys will see in a moment why I'm doing this. Integers, the symbol is Z. I think it's like that. Dot, 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 -2, -1, 0, 1, 2, and so on to negative and positive infinity. Now, a rational number, we need to remember this because rational numbers are defined as something that can be written as an integer. Okay, that's very bad. Let's do that better. As an integer divided by an integer. I'm writing this very loosely, but this is how we will define a rational number. Something that can be written as integer over integer. Okay. So now given that, we can look at a few examples. Is 0.5 rational? This is the point where I pause and ask the class, someone tell me, think about it, blah, 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 but I don't have the time here, unfortunately, so I have to just do the thing. Think about it for a few seconds if you can. Is 0.5 rational? Right? The answer here is yes, it is rational because even though 0.5 is a weird way of writing the thing, 0.5 is just a half, right? And a half consists of a 1 divided by 2. This 1 is an integer for sure, and 2 is also an integer. So it's integer over integer, which means yes, it's rational. Perfect. Okay, is pi rational? The answer here, okay, let me put an answer at the first one. Sorry, the first one is yes. I'll put it there. Is pi rational? Very quickly, the answer is no, because it cannot be written as integer over integer. Right, we'll look at more detailed definitions for why pi is not rational as we go on, but for now, it cannot be written as integer over integer. I forget the number, I think it's 3.1415 something, 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 right? The digits don't end. It's not rational. Okay. Example 3, is 2 3/4 rational? And that's an interesting one. Is it integer over integer? Doesn't look like it to me, but it's a mixed fraction. So you have to look up all these words because I last saw them in high school. It's a mixed fraction. It can be rewritten. Sorry, I said the wrong one. It's a, what is the word? Yes, it is a mixed fraction. That's correct. Sorry, a mixed fraction. It can be written as an improper fraction. Right, so that's the correct words. Sorry for the little stumble there. 2 3/4 is a mixed fraction. To rewrite it as an improper fraction, again, you can look this up, but I'll do it very quickly. You take the 2 from the front, multiply it by the 4 at the bottom. This is the general rule. And then you add the number on top that you divide by the same denominator. That doesn't change. So what you will get here is 8, 9, 10, 11 on this side over 3. This is an improper fraction. So we move from mixed fraction to improper fraction. It's equivalent. Both things are equal. So 2 3/4 is equal to 11 over 3. So we can just look at the 11 over 3. 11 is an integer clearly. So is 3. So this is integer over integer. So yes. Right, that
It's
is
over 4.
rational. Okay.
It's
And we
divided by
can
4.
check the next ones. Let me not waste too much time. Let's move on. Example 4, yes, it's rational. I'll do them quickly, right? The next one is rational. Yes, integer over integer clearly. Example 4 is just negative a quarter, right? That's integer over integer. Example 5, 10 and 1 are both integers. And the negative, again, as I said, with fractions, you can put the negative on top, on the bottom, doesn't matter. Okay, is 3 rational? The answer is yes, because 3 can be written as 3 over 1. That's integer over integer. And negative 3, yes, because of the same reasoning. Okay, I don't think I've spoken so fast in my life before. I'm trying to, okay, anyway, we have a few more minutes. Let's do what we can. Actually, we're about halfway. Maybe I should open the floor up now since we have a few minutes for comments, suggestions, things you guys would like to see in these lectures going forward, things that you think will be helpful instead of the way I'm doing it today. This is the first day. I just wanted to see. Okay, let me go back to the chat. 11 over 4. Probably something was 11 over 4. I haven't kept track. Let's see what mistake I made. 11 over 4. Yes, sorry. This is 11 over 4. There we go. Thank you very much. Okay, I'm glad you guys are awake and paying attention and following me, even though I'm rambling and flying through the thing. Okay, let's see. Ryan, yes, thank you very much. Okay. Yeah. Do you guys not have the ability to unmute on this thing? That is a possibility.
No, we can.
Okay, anyway. Do you guys have any suggestions? Oh, so you guys are talking and I can't hear anything. That's a problem from my side. Okay. I get you now. Unfortunately, it's very late that I got you. Bottom right corner of my screen. Yeah, there we go. It's clear. It's just a damn volume is off. That's all that it is. Why am I being stupid is the question that we all need to figure out. Yeah, it was simple as, oh my God. Okay. Guys, I'm so sorry about that. Okay. Oh, okay. Sorry, guys. Does anyone want to say anything now that I can hear you guys?
Okay, so since I see no one's going to say it, there were a lot of couple of questions up top. So like people asking you to repeat stuff, especially about the partners.
Oh, okay. All right. Okay. Okay, so we did cover a good amount of material today. So if I don't get to finish that today, which I probably won't, then we'll go over some of the stuff next time. And if you guys can please compile a list of questions you have, maybe put it in the chat or send it on the WhatsApp group or something, questions, and just give me an idea of whereabouts in the slides. I'll try and answer those before the next session, so you guys can look at it before the next session. And yeah, again, guys, I'm so sorry about that. My apologies. Okay.
So I've just
Oh.
found out that we need a calculator for this. Is it any particular calculator that you would recommend?
I'd recommend one of the scientific type of calculators, maybe like the good old-fashioned Casios, maybe something that can factor polynomials as well. It's useful to have that. Yeah, I'd recommend one of those. No particular brand though, just as long as it can factor a polynomial and do good old-fashioned plus, minus, divide, all those things, then you should be good.
Oh, another learning curve. Thank you.
Okay, my pleasure. Okay, let's see. Do you guys feel okay with the format of the way the lecture has been going today? I mean, other than the fact that I didn't hear you guys, that will be sorted out next time. Amina, I had a question. Amina, do you want to say something?
Oh no, somebody was asking where can they find the lecture slides?
The lecture slides. Yes, unfortunately, I'm still waiting for access to ARC. As soon as I get that, which should be within a day or two, then I'll upload them to ARC. I'm sure you guys have access by now. So there in ARC, I'll just make a little section called lecture slides. I'll upload everything there. Okay.
Do you mind going through where to get the module faces and so forth?
Yeah, I can do that. In fact, we have a few minutes now. I can quickly show you guys. If you know how to get to the tertiary hub already. Okay, my screen is still sharing. So I'm just going to go to my SharePoint. It might look a bit different for students, but it's the same idea where you have this thing with tiles everywhere. Do you guys know how to get here firstly to your SharePoint? Okay, let me come back this side and check. You guys all good so far? How to get to SharePoint? Okay. If not, maybe just have a look at it's going to be in the video, the website here that I got to. And then you come to, let's see, student material is at the top here. You guys, I think it's a blue slide for students. Student material. Once you get here, you just look for you'll find MAPC. If you get to MAPC, then you click on term 1, and in term 1, everything you need will be there. Like the module outline, module manual, I think one of those things has a pacer inside it. So those are the two things you need from here. Okay, so just take note of that. I'm going back here. I'm going back to my SharePoint because from my SharePoint, again, just to recap, student material is here in the SharePoint. That's where you get the manual, the outline. Also, ARC is here somewhere. At the bottom, we see VC ARC, right? So you guys can go to VC ARC and let's also check if I have access now. IIE, that's the one. So access is good, but is the module showing? That's what I've been waiting for. No, it's not. These are my in-person modules. But anyway, I'll show you guys with one of them. If I go to group 1, for example, then we don't want to see all these stories now. I'm just going to click on anything here because once you click on something, the view becomes easier. So I'll just click on the module information. Right, once I click on that, everything on the left becomes summarized in a nice little thing. So I go right to the bottom and okay, for this one it's not created yet, but here where you see a written unseen exam, there will be this extra thing here that says lecture slides. You click on that, everything should be inside there. Okay, so it's not here yet because I haven't lectured group 1 yet in person, but anyway, it will be there for you guys. Okay. So that's that. Yes, the workbook is there. The workbook is very valuable for examples. So we'll see how it goes. I may use the workbook. Sometimes it gives slightly silly examples, so I may make up my own examples along the way. I do that sometimes, and then I'll upload those examples to you guys. Again, depending on the learning unit that we go through, I'll judge it as we go through the slides and the workbook, and I'll check what's more appropriate. So for the first learning unit, I'm going to upload an ICE task, which you guys can work through in your own time. It probably takes a day to work through it. I'll give you guys about a week to work through those tasks. It's just a whole lot of examples based on everything I've been covering in Learning Unit 1 slides. So that will also be uploaded with your lecture slides, all of that on Arc. Okay. All right. I've technically set the session up until 7:30. So even though we're done now, anyone who wants to leave or needs to leave, dying of hunger, whatever, you lecture is done, so you're welcome to leave. Anyone that has extra questions, you're welcome to stay and ask me. I'll be here for another 10 minutes or so. How we submit ICE tasks. Yes, that's a very good question. I'll probably make a link for you guys to just, you can scan PDFs, or maybe you can probably just take photos and send them to me. ICE tasks are not very formal. It's just for me to see that you're making an attempt. You make an attempt. I'm not really going to mark it 100%. I'm just going to check whether you have a few things in the right places, and you get a mark for trying, right? You don't get a mark for getting things right with ICE tasks. So it's free marks, right? Just send attempts and you'll get your marks. Okay, but again, I'll make links for those, and in good time, I'll share those with you guys. Okay, thank you for bringing the chat closer to me. I will join the chat. That's a good question. So usually, okay, I'll download it and probably on Arc. It's probably going to be shared on Arc. I think it's nice to try and keep everything
Sorry,
on
sir.
Arc.
I just want to give
Yes.
you like a quick example here for these students. So basically, if you're struggling to get the recording, like you as the lecturer getting it up on Arc, like as soon as the Teams meeting's done and like everything is ended, you can come back to the chats and then the class will be there as well. Like it will be at the
Okay.
bottom of the chat.
Okay, I appreciate that. Thank you. You guys are catering for the old man here who's losing touch with technology. I appreciate it. Thank you. Okay, all right. So yeah, that's the end, guys. Feel free to stay if you need to. Otherwise, all the best, guys. It's a pleasure unofficially meeting all of you. Hopefully next time will be a bit smoother. And yeah, take care, guys. All the best. I'm still here if you need help for the next 10 minutes. My pleasure, pleasure. Thanks, guys. Okay, let me stop the recording now.